not perfect. So there are two methods to do this, so I'm going to put another one right over here. We have the, hey, I know my multiplication really well and I know all my perfect squares, and this is 9 times 7. And 9 is a perfect square, and I know the square root of it is 3. Or maybe you don't know all your perfect squares and all your multiplication really super brilliantly. Not everybody can be that math magician guy, right? So we make a factor tree. I know that this will divide by 3, and it's 3 times 21, and I know that 3 times 21 is 3 times 7. Matching pairs come out. Leftovers or remainders stay in. It's not gonna. All right, so both methods again. I know that 28 is 4 times 7, and I know that 4 is a perfect square. And I know that the square root of 4 is 2. So I get 2 times the square root of 7. Or I don't know that, but I know that this is even and it'll divide by 2, leaving me 14, and that 14 is 2 times 7. And I have this pair that can come out, and that 7 that stays behind. Okay, now in this case, I actually don't know all the perfect squares that are in here off the top of my head. But it'll divide by 2 or 5 or 10. I'm going to divide it by 10. And 54 is 6 times 9. And 6 is 2 times 3. And 9 is 3 times 3. And 10 is 2 times 5. Now I have a pair of 2s. And I have a pair of 3s. And then I have this leftover 5 and this leftover 3. Okay. The 2s, one of those comes out, and the 3s, one of those come out. And that 3 and that 5 are remainders, they stay behind. And then you multiply them together. So 540 is actually 36 times 15, which, like I said, I did not, off the top of my head, have that memorized. Questions on that?